Hello, my name is Alaa from Syria. I will present to you my research about the investment of earthquakes energy to develop seismic isolation technology. Inspiration. Earthquakes are one of the most violent and destructive natural hazards on the earth. Every year, millions of people around the world are affected by earthquakes. It is vibrations that cause buildings to collapse and destroys infrastructure. Therefore, the seismic isolation technologies are becoming one of the main pillars of any building these days. And there are two main seismic isolation technologies that are mostly used: flexible junction and seismic isolators of springs beneath the building. Since the flexible junction erodes over time and the seismic isolators sometimes cannot protect buildings, we attempt to develop a system that increases damping of vibration depending on the magnetic forces and the force of the springs. Magnetic forces. When an electric current passes through a solenoid, it behaves like a magnet. And the side in which the current moves anti-clockwise direction behaves as a north pole in the magnet, and the side in which the current moves at anti-clockwise direction behaves as a south pole in the magnet. This is the equation that expresses the magnetic field of a magnetic dipole. We assume that the axis Z is parallel to the axis of the solenoid. So, the strength of the magnetic field on Z axis is the magnetic moment of the solenoid is. So, the magnetic moment of a pair of opposite solenoids forms a magnetic dipole is, and the equation expressing the magnetic force. Using this equation, we obtain the force resulting from the pair of solenoids. Electricity generation. When a piezoelectric crystal is bent or stressed, the distribution of the charges inside the crystal changes. This results in the creation of positive and negative charges on opposite faces of the crystal, generating a voltage. If you connect wires to the face of the crystal, we can make use of this voltage. Examples of piezoelectric materials include quartz, Rochelle salts, plastics, and even foam. Piezoelectric crystals have a lot of applications. One of them is harvesting the vibration energy of roads and walkways due to traffic, and use it to generate electric current. The crystal placed about 5 centimeters below the surface of the asphalt. It slightly deforms when vehicles travel across the road. Then, it produces voltage that is implemented in Japan. If it planted along a 1 kilometer stretch of road, it could provide an average of 400 kilowatt of power. Improved damping system. Now I will explain to you the working mechanism of the new system. In the beginning, the building is based on a set of springs. In addition, we put a device that contains piezoelectric crystals to generate electricity beneath the building. And we put a group of opposite pairs of solenoids beside the springs. When an earthquake occurs, the piezoelectric crystals will vibrate, so that will produce a voltage, and then we can get an electric current. When this current passes through the solenoid, it behaves like magnets. If the building elevates above the level of the ground, then we monitor this elevation using sensors. So we pass the current in the solenoid in which they behave like opposite poles, north-south. They will attract each other. So the solenoids and the springs will pull down the building. Conversely, if the building drops below the level of the ground, we pass the current in the solenoids in which they behave like similar poles, north-north or south-south. They will repel each other. So the solenoids and the springs will raise up the building. In this way, we can damage the vibration gradually depending on the energy of the earthquake. Description of the movement using equations. First, assuming that the upward direction is the positive direction. If we apply an external force on the building, then we let the building move freely using Newton's second law, we get this equation, where h is the initial distance between the solenoids. Using this equation, we can define the system damping efficiency. This system should deploy to save thousands of souls. Here are the references, and thanks for watching.